Alright. Got to try and keep these things short, so this is the second attempt. Otherwise, I start waffling. So there's been some updates. We now got the Windows performance counters, so that's giving us the rate of reads and writes on both drive 1 and 0, or NVMe disk 0 and 1. It's funny that I put disk when hard drives haven't had a disk in them for quite some time now, but there you go. So we're just going to baseline everything. We do have OBS running, but that's running to disk 0, the one with the heatsink, and we're only interested in whether adding an Amazon heatsink to an NVMe drive makes any difference at all. So that's fine. We can write to disk 0 without without affecting the test too much. Similarly, the project, it's on D drive, but I'm writing maybe like 10 kilobytes every 200 milliseconds or something. It's pretty small biscuits there, so that shouldn't affect anything. Although really I should be writing my data to the C drive, but it's going to be negligible compared to the Writernator. Now I just need to create a folder. I've only got 45 gigs left. That's because I had a videos folder that I'd copied across. So we're going to, I'm not using any arguments or anything, it's a bit sloppy, but we're going to change the Writernator to write out to dtest, and I think we're baselined. Okay, we haven't baselined long enough because I've just looked at the graph, and this is the beauty of having data that just is updating in front of my eyes. I don't got to run everything, then go look at Excel afterwards and be like, look, right before we kicked off the test, everything went bad. I'll stop recording, but I'll let it run for like another 5 minutes, and then I'll kick off the Writernator. And what are we at? We're at 49 degrees. I'll keep you here because it's going to be exciting when we kick off the Writernator. So we will we'll just hang on for just another minute. You can hang on with me, and then we'll kick off the Writernator. While we're here, actually, let's just improve the Writernator. Let's go bytes 1 is equal to rand bytes blah. Oops. And bytes 2 is equal to a different set of random bytes. And then we'll have our number of files. And then what we will do is we'll have a range. So for x in range 1, 2. So we'll put write this is equal to bytes list. Okay, oops, that's not how lists work in Python. Okay, so now for x in range 1, 2, write this is equal to bytes list x. Now I can't remember. Let's just test it, because sometimes I don't remember things and I have to test it. So range, let's just do list range 1, 2. Does that give us? It just gives us a 1. So what we actually need is 1, 3. Yes. And actually what we really need is just 2. Yeah, okay. So range 2, and then we'll say, well, if it's 1, then write this. If it's 2, then write this. And then we can do our repeating loop. So it's not beautiful code, but I'm just excited to get testing. Oh, look, it's come down a little bit. I guess that's going to have to be our baseline variance. There's not too much we can do about that, but hopefully the change between like our initial variance and the set point, once we've been running the Writernator for a little while, will be significant enough that the variance at both ends is negligible. Anyway, that is the plan. So we've got write this, which is the bytes that we want to write. And then this, we don't really need to declare a separate variable for that, so I think we'll just do this. And then we want to write, is it fwrite, fout write bytes? Yeah, okay. Let's put bytes list x. All right, so that gives us our alternating lists of random bytes. So sorry, NVMe drive that doesn't have a heatsink. We're gonna push you pretty hard. All right, there's our initial variance covered there. There's the writeinator, temp test. We've got d temp. It's actually just test. Let's just change that to test. I don't think I've made any mistakes. Let's kick off the writeinator. And bang! Immediately, the drive is up to around 6,000 megabytes there. And, oh, that is so cool. We can see the curve increasing on disk 1 temperature, which is awesome. That is very fun to see there. So, yeah, it's going to be pretty brutal on the hard drive. Just these bin files here. There's 100 of them. We've already written 100, and it's just going to go. Actually, we've written 99. Well, whatever. It doesn't matter. I'll just change that to 101 for the next one. In fact, we just need to change to that for the next one. Not that it really matters. What is important is that we're slamming it. So we'll let that reach steady state over, say, a 5-minute period, and then we will stop it, and then we'll look at the rate that it takes to come down. So we can actually make this do some control system stuff. It's not just control system stuff, it's modeling in general, but we can model these relationships, and we can come up with an expression that says, you know, it's a first order system with these characteristics, you know, tau of 10 seconds, or, you know, and a gain of, you know, 0.1 or whatever. You know, going by how we are doing our units and stuff like that, because it'll be a gain of, you know, 0.1 degrees centigrade per 100 megabytes or whatever like that. So anyway, we can work that stuff out later. But yeah, look, it's just beautiful curves. I love it. It's great, and it's all getting recorded. So if we have a look at the output file here on C drive, no, it's on D. It's on D drive. Yeah, there's our output file right there. So that's negligible compared to what is. Hang on, is that? It should flush each write. It's negligible, so it's like 122 kilobytes versus, and that's over the duration of the how long I've been running this, which is sort of around, you know, 5, 10, 15 minutes. So it's like 200 kilobytes every 15 minutes, negligible compared to all the random stuff, literally all the random crap that we're writing to the hard drive right now. I wonder, does it work out? No, because it's going to be, we're going to write one, it is a repeating pattern, but one repeating pattern, you know, 99 times, and then erase that, and then write the next repeating pattern. Yeah, the nice thing is we're not generating the random numbers on the fly, and that's because we don't. We want to just have them in memory, which should be the fastest of all. Ooh, what's going on here? So it's dropped for no reason. as far as I can tell. I wonder if this is some sort of thermal throttling or something. Oh, it's going to mess with my data. Well, it's interesting. So this is a feature of this hard drive, I suppose, or possibly operating system. We will not know. Oh, that's frustrating. That step change down. But I guess we can look at these features to see, well, it's reached a certain temperature and now it's trying to bring it down. So there's a bit of thermal throttling. So we might see that we can go harder for longer with, yeah, that looks like it's hitting like 80 something degrees and then it's sort of bottoming out a little bit. So we might find there's like a little steady state of a kind later on, but we can certainly take the highest value there and try and model it up to there. That's a pretty consistent step change there. Possibly when doing a comparison between the bytes written and the temperature, we can put a first order digital filter on that value here just to smooth that out a little tiny bit, just so that we get a realistic indication of how much of a step change it is, because it's not exactly a step change, it's sort of a bit more of a wobbly thing. It's certainly very consistent over here and becoming far more erratic later on. So I don't know whether that's just a feature of higher temperatures or whether that is a feature of obviously safety mechanisms to throttle to keep the temperature down. So it's going to be very fascinating to see what happens. Let's kill the writenator. I think we've done enough writenating for now, and then bang, straight down. So now we can plot the response curve coming down. I imagine it should almost be a mirror image, just inverted, because that's how linear systems work. Although that being said, it's probably non-linear from if you're writing 6,000 megabytes per second versus 3,000 megabytes per second, probably fairly linear between those two. But then if you go all the way down to 0, then perhaps higher gain. Anyway, control system speak. Don't really need to go to that level there. But yeah, we can definitely see what appears to be somewhat of a first order response curve there. So we'll run that for another 5 or 10 minutes, and then we'll slap a heatsink on this NVMe drive, and we'll run the same test again, and we will see if it makes any difference at all. Maybe it makes things better, maybe it makes things worse, or maybe it has negligible difference. But that will be the test. That's what we want to find. And it'll be very interesting to see between the start and, peaking at like 83 degrees centigrade, does it take longer, Before we start, I assume, thermal throttling, we'll be able to, once we put the heatsink in, we can probably come up with some other hypotheses and things. But I wonder, will it take longer to get to 80 plus degrees? And if we do, if we ever get there, I should say, it'll be interesting to see if there's that thermal throttling as well. Anyway, that's enough talking for now. Probably too long of a video, 15 minutes. It's pushing it. Well, we'll see. All right, ta-ta for now.